Have you ever wondered how does ChatGPT actually understands what you type? Let's decode with us. Welcome to Neura Arc. Here we will explore the AI system architecture for complex AI system applications. In this video series, we will go through each architectural pillar required to build a complex AI application system. The pillars such as tokens, chunking, embeddings, vectors, RAG, LLM, context design. We will go each of this pillar one by one in detail. Let's begin with the chapter token. So first we will start how LLM actually see text. We being a human, we interact using words, images or sounds. That is our channel of a communication. But the computers sees the numbers. LLM cannot process a raw text. Whatever we are going to pass to LLM, now you are using a prompt, right? For doing many of the things you are using prompt. But LLM cannot understand the raw text or any word what you have entered. Because computers see the numbers. The numbers is a mechanism behind it. Hence, this text must be converted into numerical representation. And this numerical representation, we are calling it as a token. So this is the beginning of the first chapter of our series, the token. So now let's understand, irrespective of LLM, RAG, the hot topics definitely we will cover, but why we started with the token? Because as I said, token is a fuel of a LLM. The way we consume a petrol in our car and vehicles, LLM consumes only tokens. The output of the LLM is going to be a token and input is going to be a token as well. And that is why you might have seen some applications, they charge you on the basis of usage. And how the usage is getting calculated? It is about the input token cost and output token cost. We will cover that part in the later, but keep this in the mind. The token is the base of the architecture, and that is why we started the token. So now let's understand first the fundamental problem. The models don't read, they calculate. What does mean by that? So just take an example of this. We had setback on the grass and time flew as we looked at the Milky Way. We are reading it because the words is our way of a communication. But as I said, models cannot read. And that is why we have to break these words into the numbers. So there could be different ways. Even our brain processes in the same way. You can see this, we had a short over here, short notation, but actually our brain analyze it, it is as we had, right? Similarly, when we come about a tenses, right, the past tense, we looked, so our brain inherently process look, then ed is a suffix for it, right? In the similar way, we have to teach LLM the way to read this, not to read, I would say calculate this. The Milky Way is a compounding entity, isn't it? So LLMs have been taught to calculate whatever we are prompting it, and actually everything is going to get converted in the tokens ultimately. So let's begin how the tokens can be generated. What is the exact spectrum of the segmentation? So in the previous example, we can say see the words sat back on the grass, right? So there is a one option that we can go with the word itself is going to get tokenized. So each word what you frame will be considered as a separate token. But there is a pros and cons to it. One of the main pro of it is it is going to be a perfect meaningful tokenization. The context will be created absolutely perfect. But just imagine how many words we have in the English, right? And if you want to support different languages, what would be the vocabulary? It's a massive. So it has an advantage getting too big. Now, the other option is split the words into characters. So every word will get split into the characters. Example of hello word. You can see over here, right? Example of hello word. HELLLO, and whatever you are going to type ahead is going to get splitted in the character as a token. Too simple to get calculate the tokens, but it is going to be occupying the very large space while computing the things. And as you know, LLM accepts the tokens. So a single prompt, just imagine how many number of letters it will contain and how much the compute cost it would be, right? So it will have the long consequences. So one is the too big, another is a too small, right? So there is a mean that we can use is subword tokenization, right? So we will split the word in the group of characters. That will be called as a subword, and that is what getting used in the industry. So we will see the algorithm which is getting used for this, and we will go through it, right? So this is just the representation of how the vocabulary blot would be there, or how the context dilution would be there, why we cannot use the exactly word being the exact token or individual character being exact token, right? So that is why we choose the use of this subword. Let's go through how exactly that algorithm works. Okay, so byte pair encoding BPE is the algorithm is used for this, and it is not too complex, I would say, to explain. Of course inherently it would be, but it has actually the three steps. One is giving the input, this one, then secondary is intermediate merges, and third is the final state. Okay, so initially, as per the one of the options, every character is going to get split. So here for example we have taken the word tokenization, right? So TOKENIZATION, everything is going to get split. And now we will go ahead with the second step. In this second step, actually, in short, we will start merging the tokens together. So TO is going to get merged. We will try if we can formulate the closest word, the word which is going to get used frequently in the industry, right? So the TO, then the next word can come in the K, E, TOKE. The next later we can say like N, right? And this is how it tries to merge the things, and it is an iterative process. It is not the exact tokenization is not going to be the exact what it has been represented over here, but I'm just giving it as an example. So the token can be the merged one of the tokenized token from the tokenization word, and other could be the ization, right? So this is an example. We will go through the coding, and we will check how exactly the tokenization works. But this is an example of how the byte pair encoding algorithm works. Okay. So while generating a token, the first two things always have to be in mind, right? The time plus token. So definitely we are not going to generate tokens directly, right? We will give a prompt. As an end user, to most of the applications, we will give a prompt. But behind the scenes, we have to keep in mind it's ultimately are going to be tokens, right? So inefficient tokenization reduces the context, right? So that is one of the key factors that we have to look for. And again, the way of algorithm what we have saw, right? The BPE algorithm. Now it tries to create the meaningful word sometimes, not all the times, right? And that is how it trained to work. And for that, there would be a things like a simple English word will have but which is a long word actually will have more number of tokens, sorry, less number of token, but a Chinese word, right, a complex, not too complex, but the Chinese word or maybe some word from the other language, right, even it has small characters, it may have the more number of tokens rather than the English word which has n number of or many number of characters. And that is how it works inherently, right? So non-Latin scripts often require 2 or 3 times more tokens for the same meaning. That is why if someone is trying to give a prompt in their language, it will going to consume more tokens inherently and will cost you more. We are giving an example of prompt over here, right? But this is not the only way of using the tokens. Even going forward, when we start calling the APIs, right? LLMs API, our API's input is going to get converted into a tokens. Of course, the RAG will be there. We will get the intermediate output from the RAG and we will pass to the LLM, right? But how ultimately RAG is going to get stored? The basic fuel will be the token, then of course embedding and all those things will come up, but that is why the token is getting more vital importance in this entire architectural state. Okay, so we will go through the coding example. So here in the coding I just added this snippet of this tick token, which is the library which I had used. Okay, and it is actually one of the efficient library, I would say. You can use different tokenization libraries, but I am using this a tokenization library of tick token created by OpenAPI. Okay, so we will go through the coding example directly over here. So let's go through the code. The test token is the file which I have created using a Python. You can use any language, but the Python getting most preferred one, right? So you can see the tick token is going to be used over here. Okay, and I have used GPT 4.1 mini model over here to call an API. You can have n number of models mentioned over there. You can just go to site and see the different models, and these models are actually for the different purpose. One is good at reasoning, one is good at a calculation, right? So just to being in the pilot or a demo, I am consuming this GPT 4.1 mini over here. So we are using a hello word. Okay, we will pass an hello word to the API and we will get the output of it. Okay. So I have created the client of the open API and I am passing the sample text what I have created over here. Okay. And I'm printing the model response. Along with that, I have even tried to print some input tokens and output tokens and the total tokens so that you can understand exactly how the tokens have been communicated, input plus output, and that is going to decide the cost. Okay, so I'll run uh, over here. So let me enter the command python.test. Okay, let's see the output. It will take some time, but okay. So you can see the input tokens are 10, output tokens 10, total tokens 20. And I have even printed the IDs of the token. So you can see the token ID generated for hello is 13225. For word it is 2375, and for exclamatory mark the token ID is 0. But have you observed one thing, right? So total input tokens are 10 even though we have only generated 3 tokens, right? So why is it? Because even though we are sending 3 tokens as a hello word over here, the system adds a metadata to it in terms of a role, or some tokens get added in terms of messaging the frame. Of course, the 3 tokens would be itself for the hello word, and there will be some extra overhead maybe added by the system, right? So we need to keep these things in mind, but it will not affect much on the cost. But yes, it will not be the exact tokens that you have generated to pass it as an input. There will be some more tokens will get added to it. Okay. And one of the thing that I need to mention, right? So we have different LLMs. I have used over here the GPT's one, right? You have the Gemini, right? And the tokenization algorithm for every LLM is a different. So it is not required that always you will have the same token 13225 getting generated in the other LLM, right? For other LLM. So that is going to get different. The algorithms and structures are bit different inherently. Not much, but yes, they are. And that is why they differ in the speed and the calculations in internally. Okay. So we have seen this, the response, right? What we have received as a response over here. Just give me a sec. What we have received, we sent hello world, and what we got, hello, how can I assist you today? And this entire cost us for the 10 tokens. Now you have understood how the difference it is between the input tokens and output tokens, right? It is not the exact word per se, it's a bit different over there. Okay. So that is one part, and the other part which I explained you, if you have some random word, right? So let me edit this thing and I'll put some random word, right? And we'll observe how many tokens are going to pass as input. I'll run it again. Let's wait for the output. See, the input tokens are 11. One more extra, but you can observe the hello word was a bit shorter than this, right? And you can even see how the breakdown has been occurred over here. SD has been one of the token. HRA is one of the token. The obvious word could be HRA for many of the reasons, right? Then AF. So 19879 is for SD, 70887 for HRA, and 1553 is for AF. And yes, the exclamatory marks remain same for the 0. So that is how it is getting generated. So whenever you are giving some input through prompt or through API, we have to be precise what exactly we are passing. It has to be meaningful, and that will help us better. Of course, the typos even can be understood by the LLM, but they will cost you more in terms of fuel, that is a token. So that is why we have to be precise on that. So let's move to the next part of it. Why tokens matter practically? Because model can only process a limited number of tokens. That means there is a limitation over the model that they can process simultaneously. So for example, 128k tokens is a limit that model can process simultaneously. It is used for processing the inputs with the context. So if your input exceeds the maximum limit of 128k tokens, then some models may give you the error, or some may will truncate the tokens. So that is why you will not be seeing the good quality of the output. There might be sometimes a noise in the output if the truncating happens and all that. So we have to always keep in mind the conversation, like input and output tokens should not exceed limit of the model's token. So what we can control and what we cannot control is the next point that we should keep in mind. Obviously, we cannot control the algorithm and the tokenization. So when we are passing a prompt with respect to model, how the tokenization is going to get happen of our prompt is the thing which is out of our control. It is up to the LLM which has been designed. But definitely what we can control is a prompt length or the input length. So there are different techniques for that, the prompt compressions and all that stuff. Definitely, again, while designing a RAG, which is the one of the main topic that we are going to see in subsequent videos, the chunking happens on top of the number of tokens. So while there, we need to consider and have some control over the tokens getting involved, defining the chunks. And of course, the third one of the important point is conversation memory strategy. To have our context maintained throughout the conversation is equally important to get the exact and expected output. Otherwise, you may see some hallucination or some noise in the output. So to have the conversation memory within a context is even under our control by defining the strategy over the tokens number that we are going to process. We will cover all these points in subsequent chapters going ahead. But for the next topic, we will first see one of the major architectural pillar in the designing AI applications, the complex AI applications, that will be RAG. This is the component which acts sometimes at intermediary layer between the input and the LLM. So stay tuned with us for the next topic, RAG. Thank you.